All right, good afternoon, everybody. Okay, so today's lecture, we're going to be reviewing the rule of three, and then we're also going to be implementing everything that we've learned up to this point. That should work. All right. So hold on for a second. There we go. So everything that we're going to learn up to this point, we're going to combine together into several concepts. So we have lecture 6 as normal. And I want to first, before we even go into everything, I want to describe the motivation for this lecture, because I kind of put this one together. And what's going on is everybody in this class is pretty much falling into one of two different populations. You have the one population who maybe had experience with Java or some C++, and you're a little familiar with classes, and this has been kind of boring you to tears. The coding challenges went by pretty fast, and you're champing at the bit to really start getting on data structure. Come on, I got Google interviews to crush. Let's go. Come on, this is too slow. Then you have the other population who have coded almost entirely in C, have never really worked with classes before, and now really want to gain this experience. And with object-oriented programming, it's actually a different form of computational thinking. So if you're trying to get familiar again with recursion, or you're trying to get familiar with these classes, it can actually feel like your brain's breaking a little bit. And both of those camps are okay. Today's lecture is going to bridge the gap between those two. What we are going to do is we are going to actually build a class, but we're also going to be learning the things underneath. The one thing with Java is if you're working with Java, Java doesn't deal with anything with pointers. This is on compiling to the Java virtual machine, and all this pointer stuff is taken care of for you. But it can be very cumbersome. The more you're reliant upon the machine, the more overhead that it entails. And so when you're working on things like wearables or automotive environments that have very small, very limited amount of memories, for example, the new Mars rover that's on there, that's coded in C++. And the reason why is because you have to be very focused on memory. So there's this trend towards low power, low memory computables that people can take everywhere they go. And that's why you see this rise in C and C++. So we're going to combine all these concepts together. So the first thing I want you to do is I want you to bring up your Sakai, and we're going to work on this problem 1 together. And so what's going on is we're going to be able to identify issues in this code together, because there will be a problem. For those of you who have already worked on Coding Challenge 2, you've seen there's a problem like that. There's going to be a problem like that in Coding Challenge 3. You're going to see this over and over again. If you see a problem that I'm asking something similar to it over and over again, where do you think you might see it? Yep, very good. You're going to probably see a problem very similar to this on the midterm. So the first step is we're going to work through this together. And then I'm going to review this rule of three: constructor, destructor, assignment operator, and particularly the copy constructor. And then what I'm going to do is I'm going to code a templated class from scratch. Just like I did in this Lab 3 video, I want you to see the process that I go through when I'm coding an assignment. It's very common for new programmers. They'll try to write everything. They'll try to put the makefile together. Then they compile it at the end, and they have 150 just pages upon pages of compiler errors, and they look like they want to cry. The reason why you want to take it this way is you can nip problems in the bud as they come up. So first, what I want to do is when you're doing a problem like this, so we're doing this problem 1 working together, is you want to take it step by step. Don't get overwhelmed by the size of the piece of code that I give you. That's not what you should be testing. What you should be breaking it down is, does this look right? What is wrong, and why is it wrong? So here I have a templated class A, and what's going on here is that template class T, I have class A here, and I have private members T the T and U the U. So does anybody see any issues before we go through anything else? Yes. Yes, we don't have a template for class U. So U is not a what we call a primitive type. So integer, long integer, double, float, character. Those are primitive types. We have to be able to define everything. So what we're going to do is we need to say that class T, comma, class U is how we would have to do this class. So if you're seeing these templates and you see that they don't match, that's highly likely a problem. And so we see we have two generic types, T and U, but only declare T. That is choice A in the problem. So now let's take a look at these two constructors. Here, I have a default constructor and a member initialization list, and I say U, I say the U, and I call its default constructor, and the T, and its default constructor. Does anybody see any issues with this? Yes. They're in the wrong order. So why is the order important? Very good. So it's the underlying pointer arithmetic that we learned about with the void pointers. So for those of you who have class experience but have coded in Java, this will make you a better class programmer, because by understanding what's going underneath with the pointers, and you put them in the correct order, you gain more control, you make your data structure more efficient. So that is an issue with the code. So that's correct. The next thing I want to go over is what's going on with this const. So when you are going to be making data structures, what's going to happen is you have to be able to account for scenarios in which you can pass any type. And that includes what's known as an instantiated object. So for example, if I am creating a class A and I have, let's say it's an int and an int, so I have 12 and 10, these aren't equal to anything. Those are just the values of 12 and 10. And quickly, okay. Okay, very good. So we have a default constructor and the constructor. So the parentheses after A, we define it in the .h file when we're defining the class in the default constructor in this manner. But we do not call it in main, because that's when the C++ compiler has issues being able to differentiate it out that way. So this means it is a default constructor and that it's empty. Here, what's going on is if I have 12 and 10, those are instantiated objects. So let's say that I could potentially store a vector in this class, or I could potentially template it to an int. So a vector could potentially have dozens, hundreds of elements. So if I don't call it by reference, I'm actually making a completely new copy of the vector, and then a completely new copy of the vector again when I'm making the object. So to reduce memory, what people do is they'll call by reference. Makes a lot of sense. I'm only passing a pointer. I've significantly improved the amount of memory. But this causes an issue. And the issue is that these values 12 and 10 aren't saved as anything. It's not int x equals 10. It's not int y equals 12. It's just 12 and 10. So it's a pointer to nothing. The way you can get around that is by defining this in the constructor as const. So that way, your user can use this in any way that they choose. Do not assume that the programmer using your class will always use it the way that you've documented. Assume that somebody think of the person you know that is really, really bad at following directions, and assume they are going to write with your code. And that's why we're accounting for that with const and call by reference. Does that make sense to everybody? Just for constructors. Yeah. So I'm going to show you an example where putting const in front of it actually would cause you trouble later today. And so what I'll be going on later this lecture is that the rule of 3 thinks of it the same way, that people are not always going to do things the way you were hoping for, and so that the rule of 3 tries to account for all these situations. So far we have A, C, and E. Now we have these two. We have get the t and you get the u const. So does anybody see the issue on the screen here? Yes. Get the t should be const. So anytime you have a class method that does not change anything of the private members, it should be called const. And so get the t should be defined as const, so that is choice F. Does that make sense so far? I should mention that my little spiel at the beginning was an open invitation to pester me with questions, right? Classes are important, and I'm monitoring the Slack as well. I'm gonna try to monitor the chat too, so that way everybody can kind of wrap their heads around these kind of concepts. Okay, so now we have class B. So here I have class T, class U, and class V, and then I have two private members, a templated class A, templated a T and U, and a V of what I call the V. So what's going on here, if we're looking at it, notice that I don't have a public keyword there. The difference between the C struct that you learned in Fundamentals of Computing, or Intro to C++, C and C++, and the classes is that structs are by default public. So you're writing in your coding challenge 2, you're writing and or not that are structs. So it makes it easier to access the members. With classes, you want to have a little security. So you say private to the private members, and then public to the things that you want the user to be able to do only. So for example, let's say that you are running the student database. Somebody shouldn't just be able to come in and change the person's social security number at will, right? There should be levels of security, levels of data hiding, that once that object is created, it can only be changed under certain circumstances that we control. And it turns out that in this example, that was the only issue with the constructors and the design of the class. When you have this, I had an option that was wrong that says, if you're going to do this, you have to do class A, T, comma, U. That's not correct. You just want to have all the types that you're going to template it to here first, which means that when you create your A object, it does that correctly. And we have the V. So this is a correct class template. We see that for the default constructor, A and the V are put in the correct order. So we have a question in the Slack. Wouldn't you still not be able to put 3.14 in the constructor even after, since it's expecting a call by reference? The const overloads that. What the const does is it creates a temporary value underneath the hood, so that way it can reference that and dereference that. So it's abstracted, the complexity is extracted from you, but you're still able to do it. So did that address your question? I see we have another comment in the chat. Why we don't have to put class A? No, what are you talking about? Here in the templates? Yes. So for the templates, those are the generic types, meaning that that's the thing that we can fill in the blanks. Class A is not generic in and of itself. Data and structure being separate. Class A provides a structure of which we then say we're going to fill in generic data. So therefore, anything that is generic should be put into the template. So the generics are T, U, and V, and class A is defined when we include it. So did that address your question? Awesome. Okay, so then we see that I have everything correct in the overloaded constructor. And then this last thing is you're able to call A's constructor in the member initialization list. So you're able to pass it like this. So this is a valid way to do a constructor. So now let's take a look at this friend operator. So what happens is, if we're going to print something out, what we can do is you can do standard cout, and I can say, I'll just say the B for now, right? But then I can do this. And then we'll do 3 or something like that, and then we'll do endl. So it propagates along. So what we're doing is, if we want to print out a B object, we have to call B. The operator before it is called the output operator. And then before that, that is the stream. And so we're actually calling operators several times throughout the course of that code. So in order to do that, we have to propagate it along. So the first thing is that we have to call by reference the output stream. We're not passing a copy of the stream. We have to make sure that we maintain where we're pointing to, because that is a abstracted version of a file pointer. Likewise, because we're moving it along, we have to return with a call by reference. Since it's an operator, we want this to be const B, right? So it's going to be const B, but it must be templated. So that's going to be T, U, and V. And then we're going to call by reference. So that way we're only doing a pointer. We've templated everything that we need to template, and we print everything out. Does that make sense so far? The last thing we need to do is, because we're returning with a call by reference, we don't have return out here. And so for the animations, we're going to we have to change it to const B templated call by reference, that is choice L. We have to return out, so that is choice M. And then we have to return with a call by reference. And so I've included as a comment the correct code, and that is choice N. Does anybody have any questions about this so far? All right, I see there's a question being typed up. So let me set up class template constructors. And what's going on here is I have classes T and U. And okay, so I'm now getting chat. Where were all the correct choices for 1? So that's in the slides. I've been presenting them in time. So if you want to go back over the slides and update those, please do so. And so M is being asked about the justification. Choice M is because we have to return out. Okay, please go back over the slides. The answers are presented for that problem in the slides. I have to continue. Okay. Okay, so when we have types here and we have constructors, we just have to make sure that in the constructor that they are matching. So we have T, the T, and we can match them like that. We can also do const if we expect that, but this is just a generic example here. Okay. For those of you chatting about the answers, if you could please stop doing that, I would be appreciative, so that way we can continue with lecture. Okay, so it is in the slides. Please review those answers. With destructors. With a destructor, what is going on is we have one of the things that we learned about with this void pointers and casting and doing all this is because we're allocating memory on the data heap for different objects, right? When we create a destructor, we have to account for the situation when we're pointing to memory like we did with an int star or char star and malloc, right? Because that memory is allocated on the heap. So we have to free it. So in the 90s and 2000s, it was very common to say that Windows had to be shut down every 12 to 24 hours because the computer would get significantly slower. The reason why was because pointers and freeing memory wasn't being done that much, or not as efficiently as it is now. So what happened is, when you have all these blocks of memory that haven't been freed, the operating system was taking longer and longer to find free memory in order to do the program. So therefore, we have to be very mindful of cleaning up memory, which is where this idea of a constructor comes into play. So a destructor, in the .h file, you have a tilde, you have an A, and then 2 parentheses. And if there's no pointers, you can just leave it be empty. It'll free up all the non-pointer memory there. What will happen, and I'm going to show you an example a little later in lecture, is if you don't free that, it leaves it there and we hit issues. So there's the notation again, and it's the equivalent to calling delete this. So it frees all the memory that's pointed to by the this location on the data heap. All right, so question, could you explain what TU and V means? Okay, so that is a generic type. You can fill that in with int, float, and double. And the whole idea is that, and we'll go over this in a lot more detail later in this lecture. The idea is that you can build it up in order to be able to show precisely the type of memory that you need to do. You can make the structure more flexible with the data structure that you're trying to make. Did that address your question? Okay, awesome. All right, so the rule of 3 situation we're going to go into here where the user doesn't use your code exactly how you were hoping. If you have to write one of these, you need to write the other 2. So the way it will work is if you have to write a destructor, a copy constructor, or an assignment operator, you must write the other 2 in order to ensure that you're properly freeing memory and allocating memory whenever and in whatever situation a user might try to allocate your program. Okay, so the question is, why do you need to define a constructor if everything is deleted automatically? It is because it's not deleted automatically. So we have to discuss what's going on. We'll get to that a little later in lecture. Okay, Kristen? So here I have a copy constructor and assignment operator. So if you have to define the destructor, the copy constructor, or the assignment operator, and an assignment operator is operators equals. Copy constructor is when you bring in a different object of the same type and make a copy of it. So if you have a copy constructor, you're making a copy. If you're doing equals, you're bringing it along and assigning it the same way. The assignment operator is called if you're doing something like A equals B. And the copy constructor is if I do A, say int float, A1, and then for some reason A0 is what I'm copying to it. So you have to account for if the user tries to do either of that. So the assignment operator, I always started off with if this does not equal &assign. What that means is if this does not equal the address of assign. Remember that this contains the address of the base address of the class, right? And assign is the right-hand side. So if I'm doing A equals A, there's no reason to do all this extra work. Does that make sense? So what we're doing there is we're trying to save efficiency, especially if the class objects are much bigger. So that's what's going on in that line of code. And so that's what I've just described that's in that text. Otherwise, what I'm doing, this.x equals assign.x takes these private members and copies them, which is why we call it an assignment operator, because we're assigning it, we're assigning it to the other one. So it's an assignment operator. And at the end of the assignment operator, we always do star return this. Then I define some get set methods. We've discussed this in detail about which ones should be constants, which ones should not be. And then templated operator. So here I have an equals equals. I have a right-hand side. And I tell the computer what it should do if the values are equal or if they're not equal. So I'm taking in an object, but I'm returning a Boolean. So if they're not equal, means the not equal address, then I say this x equals RHS.x and this y equals RHX.y. I am telling what the computer should do if this operator is called. If they're the same, then I just return true. We've gone over this friend operator. The crucial things are call the OStream by reference, make sure you bring in a copy of the object, and then return the output stream with a call by reference. Does that make sense so far? Okay. Okay, so here the question is it's being called as a pointer. So here I could just say this dot x, or I could even, for simplicity's sake, to make it even simpler, I could just say return x equals equals right-hand side dot x. All right, Natalie, did I address your question? All right, and Kristen, I promise I'm getting to your question. All right, so what I want to do is go over that code from problem 7 in lecture 5 and show you what's going on underneath the hood so you can see what's going on when we don't have pointers and we're doing templated classes. So first thing I do is I call main, which puts a copy of the main code onto the instruction stack. Then I'm going to call an overloaded constructor for class A where I am templating. Hold on, let me go to the chat first. Okay. You go to the chat first. Now, if I'm creating an object of A that is templated to int, what's going to happen is I'm going to call that constructor. And now I'm going to first create a this register that's pointing to the location. And then the template's going to say, what am I going to do here? TAN, TBN, and it's templated to an integer. So it's going to say, all right, I'm going to allocate an integer, and I'm going to allocate another integer. And so that's what the constructor is doing. And then I'm calling constructor, except it's templated to a double. So what that's going to do is I'm going to create another register to point to the second class object. And now it's going to say, well, I've got a generic template. This time it's filled in with double. So now I'm going to allocate 64 bits in for the double, and then another 64 bits in for the second double. Does that make sense? So now I'm going to call getDiv. And so what's going to happen is it's a method of the class that can access the private members. And it's going to save it as an integer. An integer, when you do 3 divided by 2, it lops off the remainder and just makes it 1. So here you can see an int getDiv, it's equal to 1. And then I call getDiv again for double, and it's 3.3 divided by 1.1. And that saves it as 3 and prints everything out. And so, Kristen, this is the first half of my answer to your question. When we go to return 0 and we have these objects there, the destructors are abstractly called in the opposite order of construction. So it's going to destruct A2, and then it's going to destruct A1. So inside, it's going to call the destructor. I would say destroyed, and it's going to print 3.3 and 1.1. And so what I'm testing when I ask, what will this code produce? Do you understand that how classes are structured and allocated in the computer? So after it destroys it, it's going to free the memory on the data heap, and then it's going to free that register. Then it's going to call the other destructor for A1, and then it's going to free that memory, and then it will remove the code off of the instruction stack We return 0, the operating system knows that we have completed the problem. So does anybody have any questions about overloaded operator, copy constructor, destructor, except for why the specific reason why we need to do it with pointers, which I'll get to in a moment, as well as templates? Let me check the Slack. And we don't see anything in the Slack, and let me check the chat. All right. So I would like you to now attempt problems 2 through 4. You should be able to identify what elements are in the rule of 3, and then be able to identify a valid copy constructor and a valid assignment operator. Okay, so for number 2, which class methods comprise the rule of 3? Who wants to tell me which ones they are? Yes, in the back. Yep, the answers are B, destructor, C, overloaded constructor, and D, assignment operator. I'm sorry, E, D, assignment operator, and E, copy constructor. Yes, that's correct. Okay, which one of these was the valid assignment operator? So Johnny Carr also correctly said B, D, and E. So which answer was correct? Which one was valid? Yes. A. So let's take a look at it. So Legabelle got the same answer, and that is correct. So we have a valid return with a call by reference because we're doing return star this. It's an assignment operator, const. We're accounting for all kinds of wild things that the programmer might do here with the const and call by reference. If it's not equal to the address of the right-hand side, then we're actually going to do work. If they're equal, we're just assigning it to itself. There's no reason to do the work. We're assigning them that way, and we have to return star by this. The reason why it is not const, as in C, is because we are actually constructing an object, which means that it's not constant. It's a new object that we are changing. Right, so Alex, did that address your question? Awesome. Okay, so let's go down to problem 4. Which answer was correct there? Who would like to tell me? Any guesses? Yes. D? Oh, B. Yeah, so William also said B. That is the correct answer. And so this is the constructor format with the member initialization list. And so B is the correct answer. Does anybody have any questions about those 3 problems? So that is the last problem. So you're welcome to go ahead and submit the problems onto Sakai. It's what I'm going to do for the remainder of the lecture. How is 3 different from 4? 3 is the assignment operator. 4 is the copy constructor. So I'm actually going to code up, and hopefully, Emmy, this will answer your question in detail. And Kristen, I know I've promised you several times, this will get to the answer to your question as well. What are the difference between all of these things, and why do we need to do it? And so what I'm going to do is I'm actually going to build a node templated class from scratch with an added bonus that we're going to have a pointer as a private member. So for those of you who are champing at the bit, let's get to data structures. What we're doing is we're going to do both. We're going to strengthen our knowledge of classes, strengthen our knowledge of templates, yet still progress towards data structures, because we're really going to dive into our first data structure on Thursday. So let me clear that out for now. So the first thing I want to show you is my process for how I'm going to design everything. So first, there are 2 files in here, but I'm just going to use them for a little bit of shortcuts later in the lecture. But the first thing I'm going to do is I'm going to say, all right, for this assignment, I need to make professional, like Google Perfetto that I showed you, having these different folders. So the first thing I would do is I would do make directory, src, and include. And then on that level, I'd say touch makefile. So now I've created those folders, and I have a makefile. And so one of the reasons why I use FileZilla, and you're still welcome to use Vim, but as the projects get bigger, I think it's easier to be able to manage everything. So now I'm going to open up this makefile here, and we see that it's empty. Now later, what you're going to see is you're probably going to want to do something like makefile init, where once you have all the folders, once you have all the flags set up the way you like it, you can just copy and paste it into another makefile and don't not have to worry about it anymore. But I want to quickly build it and show you what's going on, so that way you can see how it's built. So colon equals, right? That's a variable name in makefile. So PP, here we have GCC, GPP for for C and C++. And so there I have G++. In that next thing I have the flags. So the flags, which I described in the reading, but I'm happy to go over it again, dash uppercase O2 stands for optimization level 2. It maps your code most efficiently to the underlying machine. The next flag here is -G, which you learned about in the GDB lab. It keeps copies of the code so you can troubleshoot. Then we had WALL. Now it says all warnings, but it's all the warnings until 2011. So 2011, the C++ standard evolves, and so now we have to account for the other ones, which is why we have warnings extra. Then we have W conversion. So I've described the motivation behind W conversion involving being sure that it's a data structures class. You should be knowledgeable about how data is progressing through the machine. The next flag is W shadow. So this makes sure that you don't unintentionally have multiple variables with the same name at different loops or in main. And then Pedantic has all the rules for the International Standard Organization for Coding and how they apply to C++. Then we have W error. That flag forces all warnings to become errors. The reason why we're doing it at this level is because once you have a warning, you can no longer guarantee that your program will work in all cases as you expect. Remember, the computer has no common sense. It does what you tell it to do, nothing more and nothing less, right? So the goal is we want to make sure that production quality code, good data structures, do exactly what we tell them to do. So then what I do is I have CXX flags, and I did M64. So remember when I ran that LSCPU and we have an option to do 32-bit or 64-bit? M64 automatically chooses the 64-bit for us. Matilda, I'll get to your question in a second. And then the next one we have here is the C++ 2011 standard. This constantly evolves. So there's been a 14, a 17, a 20, and there's going to be a 2023. And so 2011 is the one that we have on the Notre Dame machines currently installed. And so this is why using namespace STD can cause real problems, because that's constantly evolving, and that namespace can cause real issues for you. Then I have effective C++. Those rules come from a textbook, effective C++, and all the rules that you'll need for that, I will teach you for this course. And then, and this will address Matilda's question about the ordering, then we want to put flags afterwards using a variable name, right? So we put them in this specific order, and the crucial thing is we choose the architecture, we choose the rules, and then we choose the optimization. So it's in that specific order. So if you have that set up, it works well enough. And then the next things I have, I'm just going to copy and paste these, are the variables like so. So these variables are for the folders. And we have a comment in the chat. Oh, no, we don't. OK. And so that tells me where all the folders are. Then we do make initialize. This make initialize command is specifically used to ensure that when we don't push executables and objects to Git, that we can initialize the folder to be able to work for us. And so I would say initialize, and then I would say mkdir, and I'm going to shorten this to include. And so here we need to create object and executable. And so the first test I would do is once this is there and it's uploaded, I'm going to say make initialize. And then do ls. And if it worked, that means I have all those folders, and now I know that I have correctly uploaded my make file. And so, Matilda, did that address your question? Awesome. All right, so next, what I'm going to do is I am going to create the files. So here's make initialize. I'm going to make the files and set everything up, and then set up the compilation before I write a class and before I write anything else. So here's how I would do this. First, I would go to include, and I'd say touch node.h, and then I'd go into source, and I'd say touch node test.cpp. So I have the files that I need. And then I would go into, you can refresh in FileZilla, and now you see that everything's been updated. And I would go into include and open node.h, and we see that it's empty. And then go to src, node test, and we see that that's empty as well. So here's what I will do every single time I write a program. I'll go to the .h file, and then I just do the if not define node underscore h, pound define node underscore h, and then do end if. So I do that before anything. And then in node test, what I'll do is I'll do pound include, and it's typically considered quotes for libraries that you create. So we're creating one here. I will go up one level and into the include library, and then node.h. Right. And then what I'll do is I'll write a very simple main, and all it does is return. And the reason I do this is to make sure that I have my make set up properly before I write anything else. Make sure that I've avoided all linker errors and all mistakes. So node is updated, and makefile. Here we want to update that. And so now that I have the structure made, I am going to create the objects that I need to create, and then I'm going to compile it and run it. So I'm going to press enter a few times here. And the first, actually, there's one last thing I'll do. I would do make clean, and I would say remove recursively force everything in those folders. Deletes all the objects and all the executables. So now what I'm going to do is I'm going to say objects for node test. I'm going to press enter a few times so everybody here can see. And this means create an object node test.o and put it into the object folder. So what you need to put here is all the code that you need, which is in source node test.cpp. From there, enter in tab, and then you have to put the G++ first, but then everything else is CXX flags -C, and then I'm going to say that I need this node test.cpp. So far, that will just create node test.o in the folder that I want. But then if I want to move it to another folder, I'll say -o, create an object, $& creates node test.o in that specific folder. Does that make sense to everybody so far? So with a template, this compiles the template. So we're not going to make one for node.h because we don't have a corresponding node.cpp file. So then what I would do is I would build the executable. And I want to run it as node test. And to make it simple, I can just move that object there. If we have several objects, as you'll be doing in Coding Challenge 2, you want to make those variables so you don't have to copy and paste that over and over again. So then I would do the same thing here. I'd say -o. And then I'm going to say where it is that I want to put the executable. So the executable is going to go in the executable folder, and I will call it node test. And then after that, we put all the object files after that. All right, so we have a comment in the chat. The $ and, what that's doing is it's saying, all right, I need to put it in a specific location. I don't want to buy anything right now. Go away. All right. This will take the node test.o and put it in the object folder. But William, did that address your question? Got it. Thank you. Awesome. OK, cool. So now that we have this updated, this is going to create the executable. And I'm going to update it, update node, update makefile, and node test. And so that allows us to be able to run our executable. So I'm actually going to do make node test. And I see that I've made some sort of mistake here. This is one of the reasons why we want to make sure that we're doing everything properly. CSE G++ node test.cpp node O. So I made some sort of mistakes. Makefile. Wait, oh, I'm in the wrong folder here. So if I go up one level, we see I'm now with a makefile. I can do make node test. And now I've actually created an executable before I've written any class. So now I know that my makefile works and I've properly linked it. So now I don't even need to worry about it anymore. And if I were to do ./exe/node test, it appears to do nothing, but we've learned with our understanding of what's going on in a computer that it's actually doing all that work. And if I test my make clean, and I do ls *, we see that the executable folder and the object folder don't have anything. So I have make clean, I have make initialize, I have all the flags I need, I have it properly linked. And from here on out, all I need to worry about is constructing my class and testing it. Does anybody have any questions? So I got the Slack over here, I got the chat open, I got the students in person. Does anybody have any questions? Please do not hesitate to ask. I promise you, if you have a question, there's another person in here who's afraid to ask it. Okay, so I see a couple people typing in the Slack. So we'll wait for a second. Why are we not creating a node.cpp for the method definition? This is because we are going to write a templated class. Right? So did that address your question? I see there's two other people typing questions, so we will make sure we address everything before we continue. Glad to hear it. All right. Nothing in the chat and nothing in person. Okay, so now I'm going to continue, and we're going to write a templated class. So the first thing I would do is I'm going to go into node.h. We see we've properly included node, so we know that we have our if not defines and defines done properly. We're going to do a template class T, and I'm going to say class node. And then when I write a class, I always do this. I'll put the brackets. I always make sure I put my semicolon after the class, so that way I don't get all these funky errors. And then inside, I do private. Then I'll do public. I'll press save. And then I'll compile again, just to make sure that I have everything set up right. So again, it compiled properly. I'll run make clean again. So now I'm going to write my private members of the node class. The node class is going to have some data and a pointer to another node. So I have T, I'll call it the data, and then templated node T star, and I'm going to call it next. What is the function of the lines with the pound in the .h file? So the if not define and define, what that does is it checks to see if there has been a library called node that has been created. And if not, we are going to make a library. So that's what's going, that's what it means by if NDF, that stands for if not defined. And then define stands for we're going to define it. Why star after T? So I'm going to dive into that in a lot more detail, but we're creating a pointer to the next node. We're actually creating a linked list of nodes. All right, so let me know if that addressed your questions, both of the Alexes. Let me know if that clarified everything for you. So now what I'm going to do is I'm going to create the default constructor. The default constructor for a node I'm going to say node, parentheses, colon for the member initialization list. I'm going to say the data. So whatever type we pass, we can call the default constructor for that data. So if it's a vector, it's an empty vector. If it's an int, it'll be an integer equal to 0. And then I say next. And if I don't have anything that I've linked it to yet, we are going to say that it currently links to null memory. So it's pointing, but it's not pointing anywhere. We haven't linked it yet. And so while you're all updating that, I have one crucial thing about this in the slides. Okay, so I've done this, if not define, empty main function, do the make file. Now we're doing a templated node. Don't forget the semicolon. Private members in order. So it's always a good idea to have data and then the pointers, and this will become even more important when we deal with trees. In order to call null, and I'll get to your question in a second, we have to include the library C standard lib. So get in the habit of this, especially as you start programming your own data structures. So here we're going to do pound include C standard lib. And this allows us to use the C++ null keyword. All right, what is your question? So the question is, we're declaring the default constructor in the .h file. For templates, because it's generic and we don't know the actual number of bits that we're going to allocate until runtime, we have to do it in the .h file. When you do know it, separate them in .cpp and .h. Otherwise, most of the things we're going to be doing are going to be templates, and so you should do it this way. Does that address your question? Is there anyone, that's an important point. So if there's anybody who is confused by my response, please let me know. Yes? Yes, it does. It extends to everything in the class. Any other questions? And forgive me if you're in the middle. I'm trying to make sure I can see through the bright reflecting off the snow. Let me check the Slack and the chat. OK. So now, once I've written a default constructor, I'm going to go back to test and check to make sure that what I said works. So here in main, what I'm going to do is I'm going to say, I'm going to create one for string. So I'm going to do pound include string for the class. And then I'm going to do pound define uppercase string for standard string. And then I'm just going to say node templated to string. I'm going to call this node 1. And that's a default constructor. And I'm going to press save on both of these. And we see that we have an issue. Class node has a pointer, but does not override these two. So we see node, const, basic string character, or operators equals. So this comes from the textbook Effective C++. And this means that I have created a class with a pointer member, but I have not created a copy constructor or an assignment operator. So therefore, we have violated the rule of 3, and I need to make those. Does that make sense? So when you come into my office hours, you'll often hear me say, what does the compiler error state? And when the compiler error states here, we have node, const node, call by reference. So you can see that even the compiler error says you should do it this way. Or we have an operator. So let's write both of those, and so we can fix our code and test it. So now let's do a copy constructor. So we have node, const, node, t, ampersand, copy. And then I'm going to make a member initialization here. Except for the data, I'm going to say copy dot the data. And we can do this because it's a copy constructor, which means that I can access the private members. So that's why I can do copy dot the data. And now I'm going to do the assignment operator. So the way to test that in node test is I would say node to string. I'll say node to actually, I'll make that as node 3, because I have something I want to do with node 2 here. So now I'm copying like so. So that's calling the copy constructor. And if I update this, we're going to see that one of the 2 compiler errors is going to go away. And now we just have pointers, but does not overrode the assignment operator. So we've made one of them go away. So now let's fix the other one. So we know with an assignment operator that we're going to return node class T. Because we're doing an assignment and we're going to return star this, that's why we return with a call by reference. Then we're going to do operator equals, and I'm going to call it const node template right-hand side. And so this is not a constructor. This is the scenario when we would do A equals B. And so here I would say if this does not equal the address of right-hand side, so when I'm writing an assignment operator, I'll just say return star this, and I'll set it up like that, so that way the rest of it is just the work. And so for here, I will say this dot, okay, so this will address your question. So for dereferencing the this pointer, there's minus arrow sign. And say the data equals RHS dot the data. And then I would say this next equals null. And one last thing, I want to write an overloaded constructor. I do const t ampersand data in. And I'll do the data in, period, comma, next null. Okay, does everybody see that? So now what I'm going to do is I'm going to say my node 2, and I'm going to use the overloaded constructor. And this one I'm going to call noder, right? Is that what I had? Yeah, noder. So now this is why we can use const, because this is an instantiated object. Noder isn't assigned to its own value in main, its own variable. Const overrides that. Call by reference allows us to preserve and reduce memory. So I can either call a string or I can define one in the call. So here is the copy constructor. And then I can say node 4 equals node 2. And that is an assignment operator. Now I'm going to get another compiler error. And the compiler error is that I have assigned something without using it. So node 4 is going to produce that compiler error. So let's go through and make sure that I've got everything squared away. Node.h, node.cpp. And that actually worked. Cool. So we have everything set up. I now know that my default constructor works, my overloaded constructor works, my assignment operator works, and my copy constructor works. So we're not going to write the destructor yet, but what I want to do is I want to write a method that allows us to be able to link these values. So here I templated node 2 to noder. Don't we need a destructor? I will get there in a moment, Matthew. So thank you for pointing that out, but we're going to get there in a moment and explain why it is, because I want to conclude the lecture with memory allocation issues. So I did node 2 is the overloaded. I showed you the make files with the copy constructor and assignment operator. And then if not this, I showed you that. Copy constructor, assignment operator, compilation. And so now here's an animation of what's actually going on. With the default constructor, I've allocated and it's just an empty string. Now remember, a string is a character pointer. So the allocated memory is a character pointer, and it's pointing to another location in memory that contains a string. And next, it's pointing to null. So you see I have the emoji there. I don't know where it's pointing nowhere. You've seen that as the 0x0 that you encountered in GDB. So then I do the same thing with noder. I create another this pointer. Data in, it's going to be a pointer to noder. And then this pointer doesn't have anything. Then I do node 3, copy. That copy is from node 0. So it had nothing there. That's also pointing nowhere. And then node 2 is the assignment operator. We see that they are not the same address. So I can set the data and then set next equal to null. And then I return this. And now we have all the values. And if I run this valgrind command, we'll see that the memory is preserved. So now we're going to write get and set methods for the node data. So what's happening here with set data is I can change the, I see we have a comment in the chat. Why do we set next to null again? Because I haven't come up with any nodes yet that I want to update. So we're going to get to that in just a moment. And I'll come back and see if that addressed your question. So what's going to happen is I'm going to go into here. And I'm going to do this void set data. And that's going to set it equal to const t ampersand data in. And since we're in the template, we just say the data is equal to data in. And this method needs to be const. Oh, sorry, this method should not be const, my apologies. This method here, const t, we're going to call by reference. We want to reference the actual location in memory. So we're going to get the data. That needs to be const. And we're going to return the data. So if it's an integer, it's really small, but if it's a huge thing, like a very long string, returning it by reference reduces the memory that our program is using. Const t returns a reference to the private member. Const ensures it can't be changed. We can overwrite that with a non-const version if we wanted to do so. So a non-const object would call that version. So now we're going to create a method that links the null pointer to another node. And so what we're going to do here is we are going to write this method, and it's going to be set next. Void set next. And I'm going to pass a node template pointer next in. And when I do it like this, what it's doing is it's passing by value the address of the node. And I would say next is equal to next in. We see that? And so what I'm going to do in main is I'm going to start linking them. And I'm going to say node1 dot set next. And I want to pass the address of node 2. And then here, I'm going to set, sorry, this should be node 1. Node 2 should be the address of node 3. And node 3 will have node 4. So now we're updating and linking. So first I'm going to compile and make sure I did everything properly. And we have. And now I want to show you what's actually going on here. At this point, everything's pointing to null. So when I call this, it's going to call the method for node 1, and it's going to have a copy for next in, and set this value here that's currently in red to point to that location in data memory. Does everybody see that? That is a crucial portion of how data structures work. Then next, we're going to do it for set next 2, and we're going to do the same thing. We link it, we set node 3, and we link it, and then the last node is still null. We're going to use that knowledge to know when these linked lists and eventually trees terminate. Does that make sense? Okay. So Kristen, didn't you say in an earlier lecture that this pointer variable is the same as variable? That is correct. I just wanted to introduce it to reinforce the knowledge. But yes, Kristen, you're absolutely right. So that's what's going on there. And so next I'm going to write a method that prints the values in reverse order. So now I want to combine classes, I want to combine the memory, and we're going to do it recursively. So first what I want to do, I'll make sure I have this in the correct order, is I'm going to call them in main. And so I'm going to say node 1, what did I call it? Set data. So we're going to do this recursively. I want to print out, let's go Notre Dame, but we're going to put Dame as first, right? Like so. Node 2 is already Notre. Node 3 dot set data is going to be go. And then node 4 set data is going to be let's. And so now what I'm going to do is I'm going to write this method where I am going to pass the address of the first node. We're going to recurse to the end, and then we're going to print backwards. And so what I need to do in order to do that is I am going to call a private method void, but I'm going to template. I'm going to call void print list. And to call void print list, I'm going to say const. I only want to pass the pointer, but what we're going to see later on, actually, no, this is fine, the node. But eventually, when we have to change pointers, we're going to do things like that. We're going to call by reference, so we can change a location. So now I'm going to say if the node dot get next. Did I write get next? I apologize if I didn't. I did not. So I have get data, set next, and I'm going to say node t star get next. And return next. And that provides us some data hiding. Now what that's going to do, if we say get next, we get that value. And if it's not equal to null, then we're going to recursively call print list. And I'll say print list, and I'm going to pass the node get next. And we're going to keep going until we hit null. And once we hit null, we've reached the last node in the list. So now what I can do is I can just do cout the node.getData. Make sure I've updated that. Right, so cout, I didn't define them, and I didn't define IOStream. So this is one of the reasons why it's a good idea to do them piecemeal like this, so you can catch the issues as they show up. And then if I run -exe node test, well, I just need to call that in main. I would say print list, and I'd say give me the address of node 1. So we're reducing the amount of memory that we're consuming that we do this. And I see we have the node.getNext does not equal node. Oh, yes. So this gets back to a question that was a little earlier. So my apologies. Since it's a pointer, we need to dereference these 3 lines. What did I do wrong now? Oh, because I got to do that const. There we go. And we see what prints out, let's go Notre Dame. So I want to show you one last thing about the destructor, and this will get to the question, and then I'll dismiss from class. So that's what I just wrote, print the values, and it goes through, and it's actually going to recursively go through everything, and then it's going to print out, let's go Notre Dame. So now the destructor. If I want to do destructor in node.h, I would write it like this. I'd say destroy node, and I'd say delete next. So now I'm freeing it, but we have an issue that's going to come up. I'm going to have a deliberate compiler error. Well, it's not going to be a compiler error. The code's going to work fine, but we get that nasty thing. You see that it works properly, but it does a memory map trace. And the reason why is because when I do delete next, it calls delete next, and it goes all the way recursively, frees the memory, then comes back up, frees the memory, and frees the memory, but forgot to tell the operating system about the this pointer. I mean, all these this pointers. So they still are going to try to look for memory to free. And the reason I wanted to share this with you is because I had a buddy of mine who didn't understand this concept. And so I helped him out, looked at that, and oh, you're not freeing your memory the right way. And he got so mad, he chucked his water bottle and broke the window in our lab. So I want you to understand what's going on there. So the way to fix it, and I'm going to copy this from here, and then I'm going to dismiss. This node text fix.cpp, what I'm going to do instead is I'm going to write a method called add to end. And add to end is going to recurse to the end and then call set next. And all we're doing is we're just going to create one node and the rest of them are linked together. So if I do this and put this in node test.cpp, and I hope I've done this properly with the node, get next, get data, and all that. But when we compile this and run it, we're going to see that no matching function add to end. Wait, what? Print values. Add to end, right? Put all that stuff there. Add to end, copy, string, node test.cpp, a v. Yeah, that's probably what I did wrong. It's going at line 15. Line 15, no matching function call, add to end, node star base const. Values. Of course, the flourish didn't work, right? That's right, I'm about to really go over on your time. But what's happening here is I recursively add the elements to the end. And we do this, and there's only one this pointer. So when we do delete next, it frees everything, and there's no excess memory. All right, does everybody, yes? Did I misspell node? All right, I'll check that. Thank you for pointing that out for me. So what we've done, we've built a class together, and we've also built the fundamentals of a singly linked list. Does anybody have any questions? So Kristen, that was hopefully the destructor, answer your destructor question. The destructor is in the header file right here. So that note, you're free to go. So there's the destructor, and I'm able to call it that specific way. So Natalie, did that address your question? And Kristen, did I address your long-term question? I'm sorry it took me so long to get to you. Oh, everybody's gone? All right.